In this video, we'll cover some IP network basics. And when I mean basics, I really mean just the very basics. We're not going to give a full CCNA level class on routing and protocols and all of that sort of stuff. But I just want to give you some of the most basic concepts. And that way, as we kind of work our way into more advanced topics in other videos, like NSX and the distributed logical router, you'll be able to understand those concepts because you'll have a basic understanding of IP networking. So let's take a look at our diagram here. And in the diagram, we can see we have two different networks. And on the top, we've got the network, I'm calling it the 10.1.1.0/24 network. And that is our IP network. So that means on this network, we have a /24 subnet mask. Right? That means that the first 24 bits are part of the network address, and the remaining 8 bits, or my 0, that's part of the host range of IPs. So based on that, we can kind of ascertain here that the range of IP addresses available is 10.1.1.0 through 10.1.1.255. We typically do not use this first address, 10.1.1.0. That's the address of our network. And we don't use 10.1.1.255 unless we have to do broadcasts. So our actual usable range of IP addresses will be 10.1.1.1 through 10.1.1.254. And I've got these machines connected to the same switch. Could be a physical switch, could be a virtual switch. Regardless, I've got these machines on this network connected to the same switch. And here's a layer 2 domain. Right? Here's a layer 2 network interconnecting devices that are on the same IP address range. Well, what happens when my machines that are on this network want to talk to devices that are on some other network? We're going to have to use something called our default gateway. And in that case, that's this router that we have pictured here. So the router is going to act as our default gateway for our machines. And again, this is true if you have physical machines, virtual machines, it doesn't matter. You'll go into the guest operating system. Right? Let's assume it's Windows. You'll go into Windows and you'll configure a default gateway for your machine. And what that default gateway means is basically anything that's on some other network. Right? Anything that falls outside of this IP address range, that traffic needs to be sent to the default gateway so that it can be routed to that other network. We can't have machines from different networks on the same layer 2 domain. Right? We can't have virtual machines or physical machines on the same switching segment if they're on different layer 3 networks. So that's what we're going to use that default gateway for. So when you think of that default gateway, that configuration that you do in Windows, basically all you're saying is for any traffic that is on some network other than this network, send that traffic to my default gateway. And the default gateway is a router. Right? The router works at layer 3 of the OSI model. So let's say, for example, we have a machine here, 10.1.1.2, and it goes and it sends some traffic towards 192.168.1.2. Some machine on the 192.168.1.0 network. Well, that traffic is going to be directed towards the default gateway. And the default gateway will receive that packet. And here's what that packet looks like. When the packet arrives at the router, it'll have a source and destination IP address. And the router will open up that packet and it will essentially analyze the contents of that packet. and it'll say, okay, the source IP is coming from 10.1.1.2. The destination IP is 192.168.1.2. And the router at this point will realize I've got an interface on that network. I've got an interface on the 192.168.1.2 network. And so it'll forward that packet towards that network where it can eventually reach the destination virtual machine. So what the router is essentially doing in our network here is it's interconnecting multiple layer 2 networks. It knows how to get to each of those networks by using its routing table. And it's going to receive traffic from one network and forward it to the appropriate network. And so what the router will have is something called a routing table, which I just mentioned. And in this scenario, we've got this router and it's connected directly to these two switches. Right? So let's assume it has a direct connection to these two Ethernet switches. The router is always going to be aware of those directly connected networks. Right? We'll configure IP addresses on those router interfaces, and it will automatically be aware of those directly connected networks, and it will build entries in its routing table to reflect those networks. So here's what our routing table will look like. It'll look something like this. We'll have interfaces on the router, and we'll have networks associated with those interfaces. So for any packets that are bound for the 10.1.1.0 network, the router will forward those packets out interface 1. And if those packets are bound for the 192.168.1.0 network, those packets will be forwarded out interface 2. Now this is really the most basic iteration of the routing table. There's a lot of other ways that our routing table entries can be populated and updated. We can use static routes. We can use dynamic routing protocols. But that's not really what I want to get into here. I just want to show you the basic concept of a router, what its job is, and what a routing table looks like. And we're not going to get into how to build a dynamic routing table or anything like that just yet. One final item of review, just to kind of talk about our OSI model. Let's bring it back to the OSI model. Let's look at our layers here. So I have a machine that is physically connected to the switch. That physical cable, that's layer 1. The physical cable between the switch and the router, and the other switch and this other router interface. Those are all my layer 1 connections, my physical media. And the actual physical switch itself and the router itself, those interfaces, that's all of my layer 1 components. At layer 2, I have MAC addresses, Ethernet network. So when this machine, 10.1.1.2, sent that packet towards its default gateway, the IP addresses weren't the only IP addresses on there. There was also a source and destination MAC address. That's my layer 2 addressing scheme. So if we take a deeper look at that packet, let's drill down into the source and destination MAC and the source and destination IP addresses to understand how our layer 2 and layer 3 addresses differ. Here's a more detailed look at that same packet that we looked at before. So in this scenario, again, this virtual machine up here, the 10.1.1.2, is trying to communicate with 192.168.1.2. And so because that destination is on a different network, what that source machine will do is it will send the frame to the default gateway. And so in this case, the source MAC address is the MAC address of this machine. Let's call it MAC A. The destination MAC is the MAC address of the router. Let's call it MAC R1. Right. So when that Ethernet frame gets sent out, the router will receive it. It'll analyze the source and destination MAC, and it'll determine at a layer 2 level, this frame is bound for me. I'm the destination MAC address. At that point, those source and destination MAC headers are gone. They're discarded. We don't need the MAC headers anymore because at this point, the communication across our layer 2 network is complete. So let's dispose of these. And then at that point, the router will analyze the layer 3 headers. It'll dig one layer deeper. It'll see the source IP is 10.1.1.2, and it'll see that the destination IP is 192.168.1.2. And the router will realize that's not me. I'm not the destination IP. And this packet is not bound for me. It's bound for some other device on that 192.168.1.2 network. So then it'll analyze its routing table and it'll determine I've got an interface connected to that network. So what does this packet look like as it leaves the router and heads towards that destination machine? Well, the first thing that we notice is the source and destination IP don't change. That part is not going to change at all. We still have the same source IP, which is this machine up here, and we still have the same destination IP, which is this machine down here. So the layer 3 addresses don't change at all. But from a layer 2 perspective, the source MAC, as it leaves this router, is now this interface on the router. And now the destination MAC is the MAC address of our receiving machine. So what I want to illustrate here is that these layer 2 MAC addresses, they're unique to their layer 2 segment. That's the only place that those addresses are significant. When we saw frames flowing within this layer 2 domain up here, those source and destination MAC addresses were relevant. As soon as that frame gets routed by a router to some other layer 2 network, those source and destination MAC addresses from up here lose their significance and new source and destination MAC addresses are appended. So what we see here is two Ethernet domains, right? We have one Ethernet domain up here, one Ethernet domain down here, and they are interconnected by a layer 3 device, a router.